from the written homework. Okay, so a research team wants to estimate the percentage of trees in the county that are infected with a new tree disease. So estimate the percentage of the trees. So to do that, a researcher randomly inspects 82 trees in the county and finds that 15 of them are infected. So let's use the method that I talked about in class today with regard to figuring out what the parameter and the statistic of interest are. So question is, does it say average or mean? No. So that automatically means, although it tells us percentage here, it doesn't say average or mean, so that means that we're interested in a pi and a p hat, a proportion of success, or a long run proportion or percentage of something. Okay, then let's talk about what is the sample. Well, random is a word that sort of points to what follows that is going to be the sample. So we randomly inspect 82 trees. So our sample is 82 trees. Okay, so N is the sample size, 82 trees, and that's the trees in the county. All right, so then let's go to population from there. So if we took some of the trees, we took 82 trees in the county, that's some of the things. The population is all of the things. So the population that we're interested in is all the trees in the county. All right, so then let's fill out what else we have in. So the statistic goes with the sample, and we already established that's p hat. So let's figure out what our proportion is, okay? The p hat is the number of success over n, the sample size. Well, if we're looking for infected trees, that's what we're defining as quote-unquote success. So we know that n equals 82, okay? So that's here, 82. And we find that 15 of them, of the 82, are infected. So that's my proportion, 15 out of 82. And, okay, good. So if I think about filling out my clipboard, all right, when I do my research and I'm the researcher and I take my clipboard, I say, okay, what am I observing? My observational units are trees in the county. We're going to inspect 82 of them. So we're going to write down tree 1, tree 2, all the way down to 82 trees we're going to observe. That's our sample, is our observational units. What am I going to look at? I'm going to look at what changes for each tree. Okay, I'm going to say my heading is what I'm going to observe, whether a tree is infected, yes or no. That's what I'm writing here. Was the tree infected, yes or no, for all 82 trees? And when I count up all my yeses, I'm going to get 15 out of the total of 82. That's my proportion of success. All right. So it says describe the population of interest. Well, the population is just the things that I'm interested in. It's not the numerical thing that I want to determine. It's just the things. So my population of interest is all the trees in the county. Okay. And then the variable is, we wrote it on the top of our clipboard here, is whether or not a tree is infected. Yes or no. And this is categorical. we wrote a category, yes or no, on our clipboard. And it says, what is the parameter of interest? Well, the parameter goes with the population. All right, we wrote it up here. My parameter goes with population. Well, my parameter is what percent? It's up here. We want the percentage of all trees in the county that are infected. So the parameter of interest is the percentage of all trees. Do this. The percentage of all trees, that's the population in the county, that are infected. All right. Then it says identify the symbol used to represent the parameter of interest. All right. So we already established that it's pi. The symbol is pi. You can just write out pi. And then it says the value of the statistic of interest. So we need to put the value. We actually have the value right up here. It's this proportion. The value of the statistic is 15 trees out of 82. And the symbol used for that, we already established, is p hat. That's it.